Hey Opties! Today we're looking at rigid transformations, which include reflections and translations. We're going to do some practice, and remember, for reflections we have reflections over the x-axis and reflections over the y-axis, and for translations we have horizontal shifts and vertical shifts. I know y'all like that little dance I just did. You can practice that at home, just do that little ditty with me, Let's take a look at number 1. This is going to be some sort of translation. So we say the function g of x equals x minus 4 squared, or the quantity of x minus 4 squared, and it's a transformation of f of x equals x squared. Sketch the graph of g of x, which will be our transformed function, and state the transformation. Probably the first thing I would do is state the transformation, because I'm going to need that to do my graph anyway. Most likely, you can also just pick some x values and substitute into the equation to find your y's and sketch it that way. But let's go ahead and state our transformation. So it's going to be, if it's a minus 4 on the inside of your parentheses, that is a right shift 4 places. That wasn't the best way to say that. Probably the best way is to say a horizontal shift to the right 4 places. So let's just write horizontal as well. We know it's horizontal because it's on the inside, and we know it's right because it's a minus. Remember, it's the opposite sign of what you'd think. And the 4, of course, is from the number 4. So what we could do is think, okay, what's our graph of x squared look like? Well, 1 squared is 1, 2 squared is 4, okay? Negative 1 squared is 1, and negative 2 squared is 4. I mean, that's pretty easy to get the general sketch of your x squared, your parent function. And we know you have this origin too, because the x squared, if you substitute 0, 0 squared is 0. So we have this, and if we want to go right 4 places, we can just take these points and put them to the right 4 places. So we can do that. So we'll take this 0, 0, and it's going to become 1, 2, 3, 4, 0. I'll make this point pretty big, and then we can go and erase these other points for our final graph. And if we have 1, 2, it's going to become 1 plus 4, 2. So it's going to be 5, 2, because we're going right 4 places. Remember, right would not affect our y values. So our y values should be the same. So the height of all these points should match, okay? That's another way of thinking about it. So that's going to be 1, 2, 3, 4, 5. You could also just kind of go off of this vertex point. The vertex of the parabola is just the point of symmetry. It's either the point at the top or the bottom, the maximum or the minimum. We also kind of call this the hill or the valley. So that point is the vertex. You could go off of that and say, oh, well, it's just to the right one and up one of that. So you know it's going to be here either way. That's an easy way to figure out this point. That's going to be left one and up one. Okay, and then if you're starting at your vertex, it's going to be 2 to the right and up 4. So that's another way you could do it. 1, 2, 3, 4. And a good check is that it's lined up with that point, because remember, our y values don't change. Negative 2 from the vertex and going up 4 is actually exactly that point. So here is our g of x. And if we wanted to, we could go and erase these little points. I'll kind of keep them there for our reference, but this is g of x. And that equals the quantity of x minus 4 squared. So we've gone 4 to the right. Several different ways you could do that. Other than kind of going off of where the vertex is, you could have continued to add 4 to each x value you had, or you could just make a table, pick some x values, substitute them into the g of x equation, and figure out your y's. But that really wouldn't be using transformations for your problem, but they'd be okay. Let's look at number 2. The function g of x equals x cubed plus 2 is a transformation of f of x equals x cubed. Sketch the graph of g of x and state the transformation. So it's another translation, and we're going to sketch the graph and tell the transformation, similar to number 1. So let's state the transformation first. If you're adding 2 on the outside, that's going to be up 2, so we can write it nice and fancy with our word vertical. So vertical translation, this is going to be the really official way to say it. Up to. You could just really, if you put up to, we know what you're saying, right? I mean, vertical translation. If you'd say up to, really you would have to say shift up to. But that would be an okay way to say it too. So either way, really the first one's the best way to say it. But if you say shift up to, it's okay. I use the word shift a lot. Okay, so let's sketch it. Our x cubed, we know we have 0, 0 because 0 cubed is 0. 1 cubed is 1, so negative 1 cubed is negative 1. So we're kind of getting the shape. 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. So kind of up here. And again, we've got negative 2 would be negative 8. So it's kind of like this. Here's some points. Remember, it's the Superman curve. So if we're going to go up to, your origin is now 0, 2. Remember, you're only affecting your y's. Your x values stay the same, so you should be in line with all these x values. Instead of 1, 1, you're going to be 1, 3. And then you're going to be 2, 10. So up here a little bit further. This negative 1 will be negative 1, 1, because you've gone up to 0, then up again to your 1. Make that a little bit thicker. Make our points of our actual g of x will be a little thicker so we can see them. And then instead of at negative 8, you're going to be at negative 6. So you went up 2. It's about here. So here we go. We're going to sketch it after we've got several points. The rule for how many points you need, just make enough where you can see the curve, right? If I only did these 3, I wouldn't really know where my tails would go as well. So it's good that I had some at where my arrows are kind of going, kind of just fill out the graph. So there's g of x equals x cubed plus 2. Okay, for number 3, we have a combination of transformations, so more than one thing happening. Number 3 says the function g of x equals negative times the square root of x plus 3 minus 5, and it's a transformation of f of x equals the square root of x. So we can see that the function family is just the square root of x. Sketch the graph of g of x and state the transformation. Really, transformations, right? We've got 1, 2, 3 transformations, okay? So let's think, what does the negative out front mean? That means some sort of reflection. So if you're multiplying by negative, whether it's on the outside or if it's on the inside on your x, 2 things that could happen. If it's on the outside, it's going to be an x-axis reflection. So let's write that first. X-axis reflection. That comes from this negative out front. If you want to kind of put in parentheses for yourself to show that that's where it comes from, go for it. This is a little bit vague because it could be a negative on the inside, but that's the only negative we have in our picture. So if you just want to put that for your own sake, go ahead. Our plus 3 on the inside of our grouping symbol is going to be left 3. So we're gonna say shift. We could say horizontal translation. To the left 3 units. That's the most pristine way of saying it. But we could just say shift left 3, and that's okay. I know y'all like my little extra voice, right? That comes from our plus 3. Remember, if it's a plus 3, it's going to be left. If it's a horizontal, which would be inside your grouping symbol, whether it be parentheses or your square root or your cubed root, it's going to be opposite sign. Really not sign, but opposite direction, right? Or negative 5 on the outside is going to be down 5. And I should have said shift, right? Shift down 5, a little bit better. And that's going to be from our negative 5. Okay, so let's think about what's the square root of x look like. Starts at 0, 0, because what's the square root of 0? 0. And the square root of 1 is 1. The square root of 2 is nothing nice, but we know The square root of 4 is 2, so that would be a nice one to plot. 1, 2, 3, 4, up 2. And then I only have 5 and 6 left. I think 3 points will be good because they're kind of spaced out, and we've pretty much filled the graph with that. So notice I only picked numbers that I knew kind of had nice answers, and I had enough to fill the graph. So you wouldn't have to figure out the y value for 2. The square root of 2 is irrational. It's just a yucky number. You wouldn't want to plot that anyway. So let's just take a look. Let's do an x-axis reflection. So what happens? You're flipping over the x-axis. That makes your y negative, okay? So the first thing that happens to this point is it becomes a y value of -1. Now what happens? Shift left 3, okay? Now we're going left 3, and now we have one more thing. We have to go down 5. So 1, 2, 3, 4, 5. Okay, that is this point. Kind of wild, right? There's a lot of things that have happened. If you want to be really nice and precise, what you could do is say that's 1, 1. So for the x-axis reflection, you can kind of do it by steps. That's going to be 1, -1. Now your 1, -1, let's apply the shift left. That's going to be subtracting 3 from your x value, okay? So 1 minus 3 is -2, and your -1 stays the same. And now let's take that result and let's go down 5. So subtracting 5 from your y value. So -2 stays the same. -1 minus 5 is -6. So let's check and see if we did it right. -2, 1, 2, 3, 4, 5, 6. Yep, we did an awesome job. I'm so proud of us. So you can do that every time if you want. It's probably the best thing to do so you don't make a mistake. But if you are good at eyeballing it, that's okay. You can also use tools like Desmos to double check, right? You could just type in your g of x and then convert it to a table and see what kind of points you have. Or you could hover over your function line to see what points you get. But let's just do this 0, 0. If you reflect over the x-axis, it's not going to change at all because it's on the x-axis. If you go left 3, then that's just simply the -3, 0. And going down 5, you're going to have the -5 y value. So it's -3, -5. And let's do this last one. Notice it's looking like so weird, right? Super weird. It's just way different because there's 3 things happening. So it gets a little bit crazy. Okay, 1, 2, 3, 4. I'm gonna write this point here because it's getting kind of far out. 4, 2. Okay, 4, 2, if I'm going to do an x-axis reflection, that is going to make my y negative, so 4, -2. And if you're doing this, you probably don't even have to think about each step along the way. You just plot the ending point you get, and that would be fine. So 4, -2. Now I'm gonna do left 3. So I'm subtracting 3 from my x. So my 4 now becomes a 1. 4 minus 3 is a 1. My -2 doesn't change. And then my 1, -2, I have to subtract 5 from my y values. So 5, 6, 7. So -7, right? 1, -7. So 1, that's -6. Here's our -7. Now, if we're going to draw the curve, my question to myself would be like, which way does the arrow go, right? But if you're thinking about, here's your regular square root of x, and if it reflects over the x-axis, the arrow is going to be still going to the right. The only way your arrow will be going to the left is if you flipped over your y-axis, which didn't happen, so it's going to be this direction. And now you can see it looks a whole lot better. Let's kind of sketch this just for the sake of looking. This would be f of x, our parent function, and this is g of x equals -square root of x plus 3 minus 5. Okay, so you can tell it's been flipped over the x-axis. It's gone down some, it's gone left some. Because if you follow each point, you can tell that. So that was a lot, but If you have like graphing tools, you won't have to do everything by hand, but it is good to know how to do it by hand to manipulate your points that way. Our last question is number 4, and it says, what steps transform the graph of y equals the cubed root of x to y equals negative cubed root of x plus 6 plus 12? So we have a negative out front, a plus 6, and a plus 12. So 3 things happening. So if we have our negative, let's figure out what happens there. Negative on the outside is an x-axis reflection. If we wanted a y-axis reflection, we would put a negative on our x. So x-axis reflection. What does our plus 6 do? So it's on the inside, right? So that's going to be some sort of horizontal translation, and it's positive. So it's actually going to be to the left. So left 6 units. And you could also say this is a horizontal shift left 6 units. So let's write that too, horizontal shift or translation. These are the really good ways to say it. And that's slash shift. Okay, and then what does our plus 12 do? That's on the outside, so it's gonna go up since it's positive. So let's write it real nice. Vertical translation up 12 units. All right, Opties. That's it for rigid transformations practice. See y'all next time.